Sure.
Okay. Thank you.
Sure, I even have a slide on that one. Let me share my screen first. All right, share an entire screen. And from this moment on, I cannot see you all, but I'm going to communicate with a few of you, and I need at least one of you to answer back to me. Can you see my screen?
Yes.
Yes.
Awesome, thank you. So, software installation survival guide. My name is Filipe Fernandes, and this talk is mostly on choices, and choose wisely or you're gonna waste the hours that you could be using procrastinating. First of all, who am I? Those who know me or ever saw a presentation that I had in other places knows that I have all this list of names that people call me, but lately I'm trying a different thing. I'm trying to say what I think I am. So what I think I am, I think I understood the meaning of developer's advocate, which is a person that pretty much is spread things between many projects and communities and try to get whatever is useful from those places into the places where he works. And I can give you a recent example. There is this software that Ujung and Emilio are the developers, EcoPipe, where they had a dependency pinned and they didn't know what to do with that. And luckily for them, I was in touch with so many other communities that had the same problem that I didn't fix it for them, but I was able to bring the solution. By the way, those who are seeing my screen right now, if you haven't watched that episode of Star Trek Strange New Worlds, do it right now. Like, this tutorial is not important. That episode is awesome. Anyway, moving on. Summary, what are we gonna be doing here? We need to install software, but how? I mean, how are we gonna install software? Software is pain. Can we reduce the pain? We can never remove the pain, by the way. That's impossible because computers were a mistake anyway. But can we reduce it? Probably. Another thing that we're going to touch base very briefly is it works on my machine and other reproducibility lies that we tell ourselves. And finally, last but not least, some demonstrations on how to do all these things. So recently I got this message from a coworker, actually from the boss of my boss. Sometimes I feel like a blind person who knows where the furniture is until someone moves it. And this person was referring to the Python installation scenario. And if you are into Python, you probably saw an XKCD comic about it, or you've been in forums where people are raving about it. It's really hard to figure out how to install stuff. Should I use my system Python? Should I use a third-party installer? Should I use the default that comes from the web page, python.org? Like, it's very confusing. So these are the questions that this person kind of proposed to me. Should I install Python or R with Anaconda, Miniconda, MiniForge, MemberForge, MicroMamba, Pixel, or Ouroboros? I promise you, just one of those are made up. All the rest are real. And I'm only on Conda land. If I want to the Python land, there are even more. So how about styling packages? Do I install them with Conda, Mamba, MicroMamba, or pip? Should I pin my packages when I'm installing them? Or should I use an environment file? And there are more questions. That's not only it. Like, can I mix Conda packages with pip packages? Should I install the Conda the full channel, or should I use a third-party channel like CondaForge or BioConda? What is the best way to replicate an environment if I choose the environment way? Or how can I install a Conda environment into another machine? Okay, now a warning before we dig into this. If you have a solution that works for you, ignore this tutorial until the day that solution no longer works. And I love this cartoon from XKCD about the moon, because we're so used to the moon that's always been there. That's normal. But if you stop to describe the moon to someone, it's pretty sci-fi stuff. It's weird concept. And this is what happens here. Like, your workflow may be weird to others, but if it works for you, if you're used to it, no need to change, right? Okay, long story short, we'd recommend Conda. But why? Or more important, which flavor? Conda, Mamba, MicroMamba? The flavor per se doesn't matter. So the whole talk from now on is probably use Conda as a generic name. And why it doesn't matter? Because Conda used to be very slow, but latest Conda is fast and is the same solver throughout all these different flavors as long as you enable libmamba, which should be default in newer versions of Conda. So you should not even worry about that. So if using Mamba, Conda, or MicroMamba, the solver should be fast and the difference should be minimal. All right, so we usually have a sing-along on OceanHackWeeks. If you watch our past videos and tutorials, you're going to see some musicals. And I hope that local people in Seattle do make a sing-along about Tell Me Why. So I'm going to tell you why Conda. Conda is a language agnostic package manager. You have to think it the Yum in Fedora world, Choco on the Windows lands, or Epty on the Ubuntu Debian world, or Homebrew on the Mac world. Not pip. Pip is a Python-only package manager. Pip, or if you're used to R, CRAM, they are Python in R-only solutions. They are specific to those languages. With Conda, I can install Python, I can install R, I can install C, C++, Rust packages. I can install pretty much everything that I can package. Also, Conda runs on multiple OSs, multiple operation systems, like Yum, Aptio are specific to Linux, Choco is specific to Windows, Brew is specific to Mac, but Conda runs on all of those. So when you're teaching people how to use it, it's one set of instructions, it's one set of commands that everybody can just type them and it should work, regardless if your colleague are locked on Windows, Mac, or Linux. And sometimes it's not a choice, right? For example, if you're a government work and you get a Windows issued laptop, you don't have a choice to put Linux in there. You must use Windows. And Conda makes it a little bit easier to digest that kind of mandatory work thing. And third, publishing your own packages is easier than the alternatives because adding your own packages to a Linux repository is kind of hard, or even Homebrew. But on Conda, thanks to Conda Forge, it's a community effort. People not only help you put your package there, as the whole infrastructure is ready for you. So navigating the installer landscape. But before we do that, let's ambiguate a few terms because people are usually confused about this. There is Anaconda Inc., the company. There is Conda Project, the open source community, and there is Conda Project. There's Conda Forge, the scientific focused open source packaging community. So these three are different entities. They are not the same. And a lot of people associate Conda with the company, but that's not true. Conda is an open source project that belongs to the community. It's not associated with any company whatsoever. By the way, right now there are more than 3 companies with stakes in Conda and participating in it, developing it, and lending developers to it. All right, now the actual installer landscape. What do we have? We have the Anaconda distribution created by the Anaconda Inc., the company. It's a MATLAB-like Python environment for scientific Python. Do I recommend it? Definitely not. It's bloated, it brings a lot of packages, and while it works out of the box, it can be very hard to install new packages on it or even update existing packages. It's more pain than it's worth it. So avoid that. Then there is the mini installer, all right? Mini Conda, Mini Forge, Mamba Forge. They bring just the Conda package manager, but that's not really true because the Conda package manager requires a Python installation and some other dependencies. So they all have what we call a base environment. And if you don't touch that base environment, these mini Conda, mini Forge solutions are great, but you can't screw up your installation if you install things on the base environment and try to make it a distribution-like thing, like the Anaconda distribution. So you have to be careful. And then there's MicroMamba. Now, this one really is just a package manager. It's just a binary that you download, add to a path, set the configuration, you're done. And last but not least, there is Pixie. I'm not going to talk a lot about Pixie because it's a brand new thing, and the author himself told me not to advertise it yet. But in theory, it's supposed to be the one ring to rule them all, like one binary written in Rust that will do the package manager, the installation, the environment management, and the locking, and all more, and etc. So stay tuned. It's probably something that future us may be working on. All right, and the winner is, in my opinion, of course, this is an opinionated talk, Mini Forge. The truth is, all the mini variants are okay. Avoid the distributions because of the bloating issues and the compatibility issues that you can have when you install new packages or update existing packages. Mini Forge, though, is already configured to Conda Forge packages. So there's less steps after you install it. Like you just install it and it's ready out of the box. If you install Mini Conda, you need to remove the default channel and add the Conda Forge channel. So it's one extra step. As a side note, I believe that MicroMamba is better right now, but it's difficult to install on Windows. So I don't recommend that to the general public, okay? I definitely recommend that if you're on Linux and Mac. But if you have to talk between all those three platforms, stay with Minifor. Okay, we know the how. Now let's reduce the pain. And that's by using environments. So this is not the environment we're looking for. We're talking about software environments. Software environments are not static. They can change with time, like I add a new package or update an existing one, but they must be tracked, shared, and easily recreated. By track them in every change that you do on them, try to track them either via Git or something similar. They have to be shareable. Like if I give you my environment, you must be able to recreate that on your machine. And I mean, by consequence, if I share them, they have to be easily recreated. Now, why are we using environments? Because environments allow for encapsulation. I'm going to give you an example that I do all the time. I use this software called NCO, NetCDF operators, and I always have the stable and latest version installed on my machine, but on different environments. So I can do different operations by just activating or deactivating environments. So this, I'm encapsulating like a single command line utility. I'm not even creating an environment to do like a full-blown Python environment work. There's always the context separation, and the context can be, like I said, a development and a stable version of the same software, or it can be a tutorial, my day job environment, or an environment just for a demonstration. The thing is, the more environments you create with different contexts, the easier it is for you to have your environment reproducible. The easier it is for you to debug problems with your environment. The easier it is for you to recreate them if you actually mess them up later. So here are some use cases for environments. When you're doing development or testing, like either locally when you're developing a library or on continuous integration services online, where just running them to run the tests on your library, or kitchen sink environment, like the IUse environment, we're going to see more later because I have some thoughts on that. Kitchen sink environments are almost a distribution-like environment, but they're disposable. Like I throw everything that I use in there every day, and if one day I mess it up, I just remove that environment and recreate it. But different from the distribution-like environments that we had with Anaconda distribution, there I would have to uninstall and install everything. With an environment, I actually literally just remove the environment and recreate it very quickly. And then there is the project-specific environment. It's something that I'll be doing for the OceanHackWeek. By the way, when I'm not seeing faces, I tend to go faster than usual. Feel free to stop me if I'm going too fast, okay? Here are some examples of environment files that you can use to recreate your environment. I'm going to open them here, just so you can take a look at them. The first one is called the environment.yaml file, which is pretty much the most common one, and Conda can read those very easily. It has only 3 configuration options, like the name of the environment can be overridden via the command line. The channels you're going to be using, most of the time you're going to be using Conda Forge only, unless you're on bio computational stuff, and you may need the BioConda one. And then just a list of packages, just the list of the dependencies. By the way, this is the environment that we have on our chapter hub for Python. Another way of creating environment is with CondaLock. So as you can see, this environment doesn't have a lot of dependencies pinned, like to a specific version. We do pin some major ones, but most of them are unpinned. The CondaLock one, they're pinned down to the version, and like here is the version, and to the build number, and they are hashed. So CondaLocks, they record, as you can see here, the address of the artifact that was used to install in your environment. This means they're 100% reproducible. You're going to have the exact same environment after you lock them. So they're extremely useful when you finish a project and want to keep this for posterity. You all remember from Joseph's reproducible research talk when he said that everything that you do with software is susceptible to some sort of rot. Like you can't reproduce, you can't install it again, you can't run it again. CondaLock helps you with that by locking your environment down to the version and build number and hash of the package. And last but not least, you can create Conda environments using Python simple requirement files. The main difference here is that you can only specify Python packages. Like with both Conda and environment files, you can specify packages that are not Python, like vi or wget, or you can even have R packages here. All right, so these are the most common formats of files for storing environments. Now let's address the elephant in the room. It works on my machine and other reproducibility lies. So how portable, maintainable, and reproducible are environments? And when should you use a heavyweight solution like Docker? So some answers, I don't have all the answers. Portability, it really depends on the packages that you're installing. For example, if you're installing TensorFlow on Linux, and TensorFlow is not available on Windows, your environment is not portable to Windows. It's only portable to other Linux machines. And you need to be mindful of that when creating a project that requires TensorFlow. Maintainability. So environments are cheap. You can remove them or create them all the time. But if you don't keep your environment file tidy, like you start pinning a lot of stuff or adding dependencies just because you want to see everything there, it can get confusing and hard to maintain. And reproducibility, like the bare bone environment file, like this one, they're not very reproducible because if a new version of Core is released next week and I install that environment, it's different from the one that I installed today because it's going to get the latest version. On the other hand, Conda log files are more reproducible because then I have them pinned down to the letter, right? And last but not least, we have Docker. And when do you need Docker? It's pretty rare for scientists to need that. Like most of the time, you can get by with log files. But if you're installing things that are not in Conda, or if you want to really freeze a VM with data and other stuff, Docker may be a good solution there. All right, demonstration. So let's simulate a scenario where an OceanHackWeek participants need to install a package for a project, work, and track them, share with colleagues, and freeze it for posterity. So right now I'm going to open a terminal and pray for the life demo goddess that everything goes okay. And first and foremost, before I do that, do you prefer this or this? Okay, no answer. Am I still
the dark one?
Dark one, let's go, dark mode. All right, so let me deactivate this environment. And I'm gonna create an environment with Conda env create. So Conda is basically pretty much like this: command, subcommand, and then the action. So the command is Conda, the subcommand is env for environment, and I'm gonna create something. I'm gonna declare a name OceanHackWeek proj because you can put your project name here. I'm gonna need Jupyter, I'm gonna need NumPy, I'm gonna need matplotlib. I don't know yet, but I'm just throwing things that I know we may need, like matplotlib, pandas, because we always use pandas, X-ray, and because I'm a dinosaur and I cannot use the new Jupyter stuff, I use the classic notebook. So let's go, let's install that. It's gonna be a bit slow because it's gonna solve for the latest version. Then it's gonna install them and download these artifacts from the internet. And once it creates the environment, I can activate and start using it. I would love if we could have some song while the solver is doing its thing. Like, you know, an elevator song. Tell me why and nothing but a Conda solver. Now, Seattle, you go. No one? Oh, come on, folks, help me out here. I can't sing by myself. All right, saved by the bell. So the environment is created. I'm gonna activate it, and I name it Conda proj, right? And I can do a Conda list. I'm just gonna clean my screen to put this at the top so you all can see. And it lists all the packages that are installed. And the beauty, I'm using actually one flavor here that's called MicroMamba. The beauty of it is that the ones that I specified explicitly are blue. The dependencies are white, but you can see here the ones that I specifically requested. Okay, so now let me open Jupyter and be classic because, like I said, I'm a dinosaur. And here is Jupyter. I have my starter project here where I import Xarray. I try to load this URL and I try to load it with Xarray, and bam, it didn't work. Why? The error tells me that I don't have the backend to read OpenDAP stuff. So I need either NetCDF4 or PyDAP. Let's try NetCDF4. So I'm going to go back here. I'm going to open a new tab, activate it, and install NetCDF4. So as you can see, I created an environment and now I'm adding stuff to it, right? We need music again. Tell me why it's just an OpenDAP link. Okay, that was quick. So let's go back, kernel, restart and run all. And bam, it worked. So, okay, now I can load file from OpenDAP. I have a data set, that's cool and all, but someone told me that there is this awesome package called CF-Xarray that can parse CF metadata and give me a really nice climate and forecast object. Of course, I don't have it installed, but I can try to put it on my environment. Let's go back to our terminal, Conda install CF-Xarray. You can see that I have my OceanHackWeek project activated here. So I'm installing stuff inside that environment. That's why every time I hit restart and run all on my notebook, I actually have the thing that I just installed. So let's try again, start and run all. Now I have CF-Xarray, I have an NetCDF4, and look how pretty this is. A CF metadata of that model. I can see that's S-grid, I can check the axis, I can see the coordinates, the extended names, beautiful. Imagine if you're creating an app that reads several models and you just want to look for temperature and you have all the temperature standard names, you can pretty much standardize workflows by using CF-Xarray. Okay, but now suppose I'm okay, I'm done with my project. I'm gonna close all this. I'm gonna shut down Jupyter. How can I store this for prosperity, right? So look, for us, there is the Conda env export -- from history. And that not only has the ones from my original command, but also the ones that I installed afterwards. So if I just send that to a file, I now can share this environment file with my colleagues. Usually I just put some indentation here just to make it easier to read. But as you can see, I already have my first environment file. And I can modify it here before sharing. For example, Filipe told me that installing Matplotlib, I should install Matplotlib base to avoid getting all the backends and make a lighter environment. Another thing that Filipe told me is that it's nice to ping at least the major version of Python, so I can make things a little bit reproducible with environment files. They don't have to be 100% reproducible, but just a little bit. And maybe if you're a stickler, you can even sort those things to keep them sorted, right? All right, now I can share this file with pretty much everybody in my group, and everybody can run this notebook. But imagine if I want to lock this for prosperity, like I just finished OceanHackWeek, I aced my project, everybody liked it, and now I want to install Conda lock, and I want to lock this and commit that to my GitHub. Oh, tell me why. Tell me why, and just like a Conda lock, I'm locking all the files. Okay, this is messing up my module. It's too fast. So I can just type Conda lock, file I want to lock, and let it work its magic. I'm not going to do it here because it is a bit slow, because it solves these environments 3 times. It solves for Windows, for Linux, and for Mac. But I am going to show you the end results of that because I just ran. And a modern log file looks like this. I have a hash for the environment on the S3 platform. I know the channel that I used, the original file that created it, and then all the list of all the packages for all those platforms or OSs. By the way, recreating an environment from a log file, it's pretty easy. I can do either this or this. The beauty about recreating, oops, sorry, Conda and create. Okay. Oh, I forgot the name. Apologies. Fashion's name, OceanHackWeek. So it's super fast because it skips the solver part. It's not solving for me because it's already solved. Now, last but not least, suppose, and I'm going to open my environment file here. Someone just told you that the latest X-ray on GitHub has a feature that you need. So you can't use the X-ray that's prepackaged in Conda Forge. You need to pip install the latest one from Git. You can do it. You can specify pip packages. You just install pip, and then you tell a list of pip packages. And more than that, you can install pip packages directly from Git. Here's what I'm doing here. Now, do this at your own discretion and be very careful, because here's what's going to happen. It's going to install X-ray from the latest Git, so it's untrackable. If I install it right now, it can be completely different from 10 seconds after I hit the install button, because someone can just commit something upstream. Try to at least ping this to a hash or to a branch. Also, mixing pip and Conda packages can lead to unexpected results because you can mix dependencies. Most of the time when you do this and you install them last, it's easier to track. But you can, for example, override the numpy from Conda. But when you do this, I believe it installs with no depth, so it's not getting any dependency from X-ray. And as magic, you can just create an environment, Conda env create file, and use that. And now we're going to see that the solver is going to take into consideration that pip package, that I'm not only installing it with pip, but I'm also installing it directly from GitHub. It could be from PyPI or local repository or whatever. So the Conda packages are the same one. It's a bit faster because they are cached locally. But now the last step, you see, it's getting it from, it's cloning the upstream repository for X-ray, and it's installing it. And as you can see, I have latest development version of X-ray. So that's pretty much it. Let's go back to the presentation. So questions. Well, I have something for you, and it's the documentation. So please read the I use installer guide if you want a kitchen sink-like environment or your personal distribution. The Conda Forge user guide if you want to package your stuff or if you want to use Conda Forge. The Conda docs, where you have way more options than I showed you here. The creating your own package guide. This is from the Python OpenSign. And if you're feeling adventurous, try Pixie out. And that's all I had. Let me stop sharing so I can see all your faces. And any questions? I know I was super fast, and it's terrible because when I don't see faces, that's usually how it happens. But feel free to bug me on Slack later. If there are no questions, I'm going to sign off into the Dungeon Master thing of disappearing because I need to pick up my kid at school. But I will log on later.
We have one question.
Oh, sure, go ahead.
Yeah.
Yeah, I think you're muted now.
No, it's unmuted. Okay,
Yeah, so I have a question for teams that are on the OceanHackWeek, Jupyter Hub. So if they want to share this environment to make sure they're all using the same environment, so would they be sharing that? I guess two questions. One, I guess they're sharing that environment file and running that Conda, environment, make, command, all that stuff. Each person is doing that. And then the second question is, does that persist? So when you log off and shut down the server, do you have to rerun setting up the environment?
Okay, so first thing first, remember when I said avoid distributions? Yeah, we are gonna give you a distribution on our Jupyter Hub. So if things are in there, don't bother installing new stuff. With that said, your project may lead you to a direction where you need to create your own environment. And if you do that, creating on Jupyter Hub should be possible and it should persist for a while. Alex, please correct me if I'm wrong, because I've been away from the infrastructure team for this year. However, it's always nice if you can do that locally as well. So you can test them on Jupyter Hub and on your local computers to ensure you have the same environment. Is Alex present in the room? Should correct me?
Yes. Yeah, so if you create an environment on the hub, it is just for you, but it will persist for the week. So within a project, we suggest that you share an environment.yaml file, check that into the repo, where others can able to build the same environment.
And it might make sense to save that environment and try it on your own computer so that when server goes away, you can recreate what you were doing. Having suffered that problem before.
Any other questions? Okay, well, thanks a lot, Filipe. Thanks for this nice tutorial and stay.
Hi, folks. Enjoy Seattle. I wish I was there with you. And I want a musical numero from you all by the end of the week. And if I don't see one, I'm going to be very disappointed. Bye.
Thanks.